All right, this is the Geometry Unit 5, Lesson 1 video over perpendicular and angle bisectors. Before we get started, I need to open the notes here. It's going to be best, okay. So in this lesson, we're going to introduce what perpendicular bisectors are, what angle bisectors are, some theorems connected to them. And then there's a few proofs in here that I'll go over for you. So you'll need to watch the whole video to get the answers for those. So real quick, there's a discussion of some topics at the top here, some terminology rather, that you need to read over. And then it gets to telling us what exactly a perpendicular bisector is. So a perpendicular bisector is a line segment that bisects another line segment at a 90-degree angle. So it forms a 90-degree angle, like you see here, and it bisects this, it cuts it into two equal parts. So we actually talked about what a perpendicular bisector was in the previous unit, but here just remember a perpendicular bisector is a line or line segment that's cutting another line segment into two equal parts. So it's a bisector, but it's also perpendicular. So visually, here, QR would be a perpendicular bisector of AB. So this blue line cuts AB in half. And then there's some other information here in this diagram that we're going to talk about because there are two theorems that we need to talk about related to perpendicular bisectors. So there's the perpendicular bisector theorem and its converse. Okay, so you'll notice they are basically the same idea, but in both directions. So in the perpendicular bisector theorem, it says that if a point lies on the perpendicular bisector of a line segment, then it is equidistant from the endpoints of that segment. In other words, if QR is a bisector of AB, then Q is the same distance from A and B. R is the same distance from A to B. So in other words, wherever I am along this line, wherever point I pick, any point along the bisector is going to be the same distance from the two endpoints. So Q would be 5 centimeters from B. Well, then it's also 5 centimeters from A. It works in reverse as well. The converse says that if a point is equidistant from the endpoints, then it lies on the perpendicular bisector. So if I can say, hey, Q is 5 centimeters from A and B, then I know that Q is on the perpendicular bisector. So how does this look in practice? Well, I'm actually going to jump pretty far down here. There's a bunch of vocabulary starting going through number 10, 11, through number 11. So a bunch of vocab at the top. But in number 12, they have these problems like the one you see here. It says you're given triangle ABC. You're given the line BD, which is perpendicular with AC. So this is perpendicular. And then we said AD is congruent to DC. Right there, they just told us that this is a perpendicular bisector because BD is perpendicular with AC, and it also cuts it into two equal parts. So that's very important because the next thing it says is that BC is 7. Okay. Well, if BC is 7, and we already know that this is a perpendicular bisector, then we're actually going to jump over here and we're going to use the perpendicular bisector theorem. And the perpendicular bisector theorem says if a point lies on the perpendicular bisector of a line, then it is equidistant from the endpoints. So over here. That's true. Then if this is 7 inches, then AB would also have to be 7 inches. So that's basically saying if this is 7 inches, then this has to be 7 inches as well. So that's going to be our answer for this. And then which theorem? Well, it's either the perpendicular bisector theorem or it's the converse. And since they told us it was a perpendicular bisector and then had us look at those diagonal parts, it's going to be the perpendicular bisector theorem. So it's either going to be these two are equal, therefore it's a perpendicular bisector, or it's a perpendicular bisector, and therefore the diagonals are equal. And so you have to go through and determine which of those is being applied in numbers 12, 13, and 14. All right, well, let's go back up to the top and look at the other set of theorems that they have for us. They also talk about angle bisectors. So the angle bisector theorem, remember, an angle bisector is just any line that cuts an angle into two equal parts. The angle bisector theorem says, erase this. Oh, excuse me. One second, everybody. All right, here we go. The angle bisector theorem says if a point is on an angle bisector, then it is equidistant from each side of the angle. That's what you see here in purple. So here we have the angle in orange, and then we have the bisector here in blue, and then here in purple we have 2 inches and 2 inches. And that's illustrating what the angle bisector theorem says, which is that if a point is on the angle bisector, this purple point here, then it is equidistant from each side, 2 inches, 2 inches. And then, of course, the converse would be the opposite. If a point on the interior is equidistant from both sides, then it is on the bisector of the angle. And you have a little illustration of it for you right there. So again, I tried to break that down into the most simple way. Let's just jump down. So you're going to be using this starting with number 16 here. Good to see we have an angle bisector situation right here. It says we have angle DEF, and EI bisects DEF. So this is a bisector. It's an angle bisector. And then it says GI is equal to 3 inches. So that's right here. This is 3 inches. And so then if that's 3 inches, then IH would also have to be 3 inches right there. And so that's what we're going to do for this next part. That also has to be 3 inches. And what theorem? Well, we were given angle bisector information, and we are proving that there is equidistant. So that's going to be the angle bisector theorem. And in number 17, you're going to do something very similar. Maybe it's the converse. You'll have to see yourself. And then we have another vocabulary question in number 18. Now, the rest of this video is going to be me going through the proofs for you. There are 2 of them, starting with this one in number 1. So I'm going to talk through the proofs, and we're going to work through these together, so make sure you follow along. Okay? It says here that CM is a perpendicular bisector of AB. So it's saying that this is a perpendicular bisector right here. That means that this is a right angle right here. It also means that these are the same length. So we've been given quite a bit of information right there. And then it says to go through the following. So we have our givens in the first line. We always have our givens in the first line. CM is a perpendicular bisector of AB at point M. And then the next one says CM is perpendicular to AB. Well, that's the definition of a perpendicular bisector. So that's going to be answer choice B. So we're taking the definition of this right here, and that's going to be what we get here. Definition of perpendicular bisector, which is answer choice B. I'm not sure if your answer choices will be the same, but you need to follow along. It's perpendicular bisector right there. Sorry about that. So that's perpendicular bisector for the second question. Then it says AMC and BMC are right angles. I already drew one of those. That's right here. So we have right angles here and here. Well, we know that because that's the definition of perpendicular lines. That's the definition of perpendicular. It's going to be right here. I'll show you answer choice F. Because perpendicular lines, by definition, means that those angles are right angles. Now, we don't have the statement for number 4. We have the reason. It says right triangle congruence theorem. That tells me that there's going to be angles that are congruent. If it says angle congruence right here, then I better have a statement here that is angle congruence. And there's only one down here that works for that. It's going to be the same two angles from the previous part, AMC and BMC. So AMC is congruent to BMC. That's going to be answer choice C. Erase that for you. All right, so that's here, answer choice C. Those two angles are congruent. And then it says M is the midpoint of AB, and that's from the definition of what a perpendicular bisector is. That's already there. Then number 6 says AM is congruent to MB. Well, we already knew that because, again, that's coming from the fact that these are being bisected. So that's going to be the definition of the midpoint. You can see here in the previous, we have midpoint. Typically, we're going to use that information in the next answer choice. So let's look down here and see what we have. Do we have midpoint? Yes, we do. It's going to be the definition of midpoint. Answer choice D. All right. Number 7 is an interesting one. Anytime you see the reflexive property of anything, you know that you're looking at something that's going to be congruent to itself. So we need to go through here and find something that's congruent to itself. And we see in answer choice C, we have CM is congruent to CM. That's going to be answer choice E. Now what they're talking about is they're basically saying that CM is congruent to itself. They're saying that this segment here is congruent to itself. All this has been building towards trying to prove that these two triangles are congruent. So if we look at what information we've got two sides that are congruent, we have two angles that are congruent, and we have another pair of sides that are congruent. And so we've proven that there is enough congruence, and it is a side angle side congruence. That's going to come from number 8. That's given. And then always, usually in most proofs that you see, the next step after proving that triangles can be congruent is going to be this one down here, the CPCTC, which stands for congruent parts of congruent triangles are congruent. We learned that in the previous unit. And that's going to be our answer choice H, and that's going to be right here. So that's going to be CPCTC. Always is going to follow any triangle congruence. And then they've done the last step for us. So make sure you paid close attention to that. Make sure you get those answers right so you don't have to redo this unit, this lesson. There's one other proof down here. Like I said, starting in question 2, you got a bunch of vocabulary. Go ahead and knock all of that out. I went over 12 through 14. And then we get to another proof. It's a little bit shorter here in number 15. It says here that AD is perpendicular to BA, and that CD is perpendicular to BC. So we have these perpendicular segments here, and that's where we see these right angles forming. And then it says AD is congruent to CD. So these two are congruent. And we have some givens at the beginning. Then it says that BAD and BCD are right angles. Well, that's coming from right here. That's coming from the fact that these things are right angles, right? We have perpendicular, so that means these are right angles and these are right triangles. So that's just going to kind of follow. So the definition of, well, that's going to be the definition of perpendicular lines. So let's find that definition of, assuming that they're looking for B there. And then they say, okay, well, those triangles are right triangles. Well, that's the definition of right triangles. So we've said those angles are right, and because those angles are right angles, then those triangles are right triangles. That's just following that logic there. Then we have another reflexive property. So that means I should be looking for a statement where I've got two that are this congruent to itself. That's going to be answer choice I. Always, that's what reflexive property is. It's always going to be something congruent to itself. Then we have a triangle congruence, HL. We learned that in the previous unit. So that tells me that I should be looking for something about triangles over here. So I know I'm looking for something about two triangles being congruent. Well, and I have that here in answer choice G. It's the only one that has that. So I go answer choice G. Those triangles make sense because those are the triangles that we looked at in number 3. And then, as always, what follows is going to be the CP-CTC statement. Always going to be the answer after you prove 2 triangles are congruent. That's answer choice E. And that finishes out our proof. So I know there's a lot of information, or at least a lot of listening. So make sure you get those proofs right. Everything else in this lesson you can do on your own. I will be posting the rest of the videos this week. So please reach out to me if you have any questions.